Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 3, 2025, about 3 days ago. This paper tests how well AI agents can navigate a huge number of online tools using the Model Context Protocol, or MCP, which is a standard that lets thousands of different AI services communicate. Using a new benchmark they built, the authors found the top model, Claude Sonnet 4, hit a 78.95% success rate. The paper is titled, LiveMCPBench, Can Agents Navigate an Ocean of MCP Tools? And as we'll see, that impressive score hides a huge performance gap across models, which they tested using a custom-built suite of over 500 real-world tools. So this first figure really lays out the problem the authors are trying to solve. On top, you have older tool use benchmarks, which often rely on unstable API calls that end in a simple simulator, not the real world. Then in the middle, current Model Context Protocol benchmarks are better. They use real tasks, but with only a very small set of tools. The new LiveMCPBench, shown at the bottom, combines the best of both, using a retriever to search through many real Model Context Protocol servers to solve complex real-world problems. Alright, so this diagram breaks down the 4 key parts of their new benchmark. It all starts with a set of diverse daily tasks, things like office work, travel, and finance. The agent then has to use the LiveMCPTool, which is a big, ready-to-use collection of over 500 tools. The MCP Copilot agent takes a user request and figures out how to retrieve and execute the right tool. And finally, the LiveMCPEval system uses another LLM-as-a-Judge to automatically score the agent's performance. This table then details how their new benchmark stacks up against previous ones. You can see other Model Context Protocol benchmarks often have very few tools or use synthetic tasks. In contrast, LiveMCPBench provides 527 tools from 70 stable servers. And critically, the tasks are time-varying, meaning they change over time, and plug-and-play, so the tools work right away without needing special API keys. These features together create a much more realistic testing environment. Okay, so this brings us to the main results. This table shows the success rates for 10 leading models across different task categories. The 2 Claude models, Sonnet 4 and Opus 4, are the clear winners, achieving nearly 79 and 71% success overall, respectively. But look at the drop-off after that. Most of the other widely used models struggle significantly, with their success rates falling into a much lower 30 to 50% range. This performance gap really highlights the challenge of navigating these complex, tool-rich environments. So to understand why so many models struggle, the authors broke down the types of errors they made. This chart shows 4 categories of failure. And what's really striking is that a full 50% of all failures fall into just one category: retrieve error. This happens when the agent's plan is good, but the system just fails to find the right tool from the huge library. The other errors, like query error, where the agent itself makes a bad plan, are much less frequent. This suggests the biggest challenge isn't just agent intelligence, but tool discovery. So beyond just error types, a big question is cost versus performance. This chart plots each model's success rate against its price. The red line highlights what's called a Pareto frontier. A Pareto frontier represents the most efficient options, where you get the best possible performance for a given cost. We see models like Qwen332b and Claude Sonnet 4 sitting on this line, making them optimal choices depending on your budget. This suggests a pretty clear, predictable trade-off between spending more and getting better results. So to wrap things up, this work provides a vital new benchmark for testing agents in realistic, tool-rich environments. The key takeaway is that for most models, the biggest challenge isn't planning, but simply finding the right tool in a vast ocean of possibilities.